Good morning, students. Today I am going to explain the next topic in your VLSI subject is your data object. Okay, so data object. Actually, the data object is a name item in a VHDL model that has a value of specified type, and the syntax, as you know that VHDL is your programming language, so some of the instructions or the syntax we have to follow. So the format or the syntax used in your VHDL for the data object is like this is signal, 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 clock, colon, bit. Okay, this is now further semicolon, and I will bold the word signal because this is your reserved keyword. So this is the syntax for the data object. So in this format or syntax, this shows the actually creation of an object called the clock. Means it will create your object named as clock, and the value which is to be held by this is your bit type. So, and the class of the object is your signal, and which is in bold. Every reserved keyword should be in bold letters. So, signal is the class of the object. Clock is the name. Clock is the name of that particular object, and the data stored by that clock data object is of your bit type. So this is the introduction about the data object. So a data object is a named item in a VHDL model that has a value of a specified type. Now further, we can divide the object, or you can say that the various types of data objects are, there are 4 types of data objects. One is your constant. Second data object is your signal. Third data object is your variable, and fourth one data object is your file. Fourth one is your file. So now I will discuss each and every 4 classes of the data object one by one in detail with its syntax and their examples, along with their examples. So you came to know that these all have your 4 classes: constant, variable, then your signal and file. Now I will discuss it by one. Okay, come on to the very first data object, that is your constant. Okay, what is constant? Actually, a constant is a data object whose value cannot be changed after it is created.
8 created. Means if I have created this, then it will remain as it is. If I have created this, then it will remain as it is. Means if I have created this, then it will remain as it is. If I have created this, then it will remain as it is. Means if I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is. If I have created this, then it will remain as it is.
data object, its value can't be changed. Means it always be a constant. So constant is a data object whose value cannot be changed. It can't be changed after it is created. And the syntax, actually the syntax written for the constant is the syntax. Now I will write for the constant is constant. This should be your bold because this is the reserve keyword in your VHDL. So I have bolded this constant, then constant name. Firstly, we have to define the class that is constant, that should be in the bold letters. Then constant name. The constant name can be anyone. Next is type of your constant colon equal to constant value. Constant value. Constant hyphen value. Semicolon. Okay. Here I am putting colon, semicolon. These all have the significance when you are writing your program in VHDL. So first, the class of the data object is your constant, then constant name, and then colon. This is colon. Type of that constant colon equal to your constant hyphen value semicolon. This is the syntax which we have to use if I want to write a constant data object. Now further, I will show these some examples from that you will understand that type of data object very much clear. So next examples are like I'm writing constant. This should be bold. Constant name I am taking as propagation underscore delay, prop underscore delay, colon, that is of your time type is your time is equal to 3 nanosecond semicolon. And another example is again constant. I am bolding this word constant data underscore, sorry, data, here it should be underscore, not hyphen, it should be underscore, data underscore with colon integer colon equal to 8. Okay, these two are the examples for the constant data object. If you will compare these examples with this syntax, then you came to know that the class of the object is written in the bold with the keyword that is constant. Now further, as you can see in the syntax, we have to give the constant name. The constant name in two examples, I have given first constant name as prop underscore delay. You can give any name. Okay, I'm just writing this for the explanation purpose. Next constant name in this example is data underscore width, then colon is put over here, then type. Prop delay is of the type of your time, because propagation delay is always given in the time. So that's why the type used for the prop underscore delay will be of your time type. Okay. And the type for the data underscore width, because we are dealing with the data, and data should be in your integer form. Okay. So I am taking data width as in the integer form. So that's why the type for that is here integer. Now colon equal to, according to the syntax I have written, equal to, time is given as 3 nanosecond. It can be varied, means you can give the 5 nanosecond, 10 nanosecond according to your example. So randomly I have taken time as 3 nanosecond with semicolon. In the last, in this language, I have to put the semicolon. Now for the integer, I have given the value 8 with the semicolon. So this was the example and the syntax used for the constant data object. So actually in the constant, there are 3 places in which constant can be declared. We can declare the constant in 3 places in the VHDL code. In the whole VHDL code, we can declare our constant in 3 places. One is in the entity, second is in the architecture, and third is in the package. Means we can declare our constant data object in 3. If I am writing a VHDL code, in whole VHDL code, I can define my constant in the entity part also, in the architecture part also, and third one is here package part also. And when it is declared in the entity part, then it will be declared after the port declaration. In the entity, we have to declare the port information also. We have to declare the port information also, but the constant should be declared after the your port declaration in the case of your entity. And this value is global. This value is your global to the architectures of that entity only. Means it is global to only that architecture when declared in the declarative part of an architecture. But when we declared constant in a package, so it will be truly global. Means any one of architecture or the entity can here access it. So when it is declared in package, it is truly global, as the package can be used by many entities. And the most common places to find a constant is in the architecture or in a package declaration. Means mostly we are declaring our constant object, data object, in the entity, in the architecture and the package declaration. And when a constant is declared, actually if I am declaring my constant in a package, its name, constant type must be specified. However, the assignment of a value to the constant can be done either as a part of it in the declaration in the package, or it can be deferred to the package body. As I've already discussed with you in the yesterday lecture, if I have the package declaration, then package body will always be there. So we can declare a constant in a package with its name and type. But if I am not specified the constant name, constant type and its value in the package declaration part, we can also assign the constant value in the package body part also. So if a constant data object is particularly with its value is defined in the package, then that type of constant is known as your fully specified constant. Fully specified constant. By name, we came to know that everything related to the constant object is fully specified with its constant name, with its type, with its value, constant value in the package declaration part. But if I'm not specifying the type or your constant value in the package declaration part, then, or you can say in the your package part, so that type of constant is known as deferred constant. DEFERRED. Deferred constant. So means value is not assigned in that case in the package declaration part. So in constant, if the assignment is deferred to package body, then the constant is a deferred constant. And its declaration in the package is repeated in the package body along with the addition of your initialization expression for the constant's value. I will give you one example of deferred constant here. The example for the deferred constant is constant. Constant is a keyword. Constant, and it should be bold. Constant. Then name is count, colon, bit type is your bit, semicolon. So it depicts that the value of the bit is not given. So that's why this is the deferred constant, as its value is not specified at the time of declaration. Means if I am declare this, because here I am declaring this, but its value is not mentioned in the declaration part. Its value will be given during the package body part. That's why that type of constant is known as your deferred constant. Deferred constant. So another example is constant keyword with bold, constant keywords with bold, constant, name is width, colon, of type is your integer, semicolon. So here again the value of the integer is not mentioned. That's why this is the another example for your deferred constant. Now with this I have completed the class data object. Now come on to the second type of data object is your signal. Now come on to the next, that is your signal. Okay, this is the second one, data object in VHDL. So signal data object actually are the logical signals or the wires. Actually it depicts the wires in a circuit. That is, it is used to pass the values in and out of the circuit, as well as it can pass the values between its internal circuits also or internal units also. So it will be work as wires in a circuit. Means if I am taking one circuit and that particular components or devices are attached with the help of wire, so this will be act as a wires in a circuit, and it can join the internal units also. So now with this I will write the syntax how we can use our signal data object in our VHDL, its syntax and the examples for the signal data object. For understanding that, I will write this. Firstly, the syntax. Syntax used for your signal is your, the first keyword I will write is signal. So it should be in bold because this is the keyword signal. Then is signal name. Signal name hyphen name colon type name, then bracket start, square bracket start, colon equal to initial value, then bracket, square bracket close, semicolon, square bracket close, semicolon. So initial value, then bracket close, semicolon. Now this was the syntax. Now I will write the examples for the signal. The examples for the signals are like signal, this is the keyword, it should be bolded. Signal, then signal count, colon, integer, range 0 to 50, semicolon. Next is signal, bolding this, Z colon std underscore logic underscore vector bracket start square curly bracket start, sorry, round bracket start 3 down to 0, 3 down to 0, round bracket close, semicolon. So firstly, I have written the syntax used for the signal object. Then the two examples are written for your signal data object. Firstly, I will explain you the syntax for the signal data object. As you can see, I will write the class of the data object firstly in the syntax signal, and it is used as a reserved keyword. That's why this should be in the bolded. Now next I have to write the signal name, then colon type name means type of your signal, then square bracket start colon equal to its initial value. I have to pass the initial value, square bracket close, semicolon. Now next the examples. The examples for the signal data object is, I have to write again the signal keyword firstly, then the signal name is your count colon, and the type name is your integer, and for the initial value I have taken the range 0 to TO2 50 with ending with the semicolon. Means I have taken the data object of class signal having the name count, and type of that count signal is your integer, and the range for that is 0 to 50. So in the next example, this is signal keyword is written, then Z is the name, then colon standard underscore logic underscore vector. STD means standard underscore logic underscore vector is the type name, means type of the signal, and the range, or you can say we have to pass the initial value for that, and the initial value for that is 3 down to 0. Why it is written as 3 down to 0? Because it's of your vector type, and 3 down to 0 means the first will be your value 3, then 2, then 1, then 0. Vector is of your 4 bit. First bit will be your third bit, second will be your second bit, then first bit, then 0th bit. So it's a vector of your 4 bits. So this was the syntax and example of the signal data object, that how we can write the or use the signal data object in our VHDL programming part. So like constant, Also, we are passing the values, or you know that constant is declared in the entity, architecture, and package part. Like constant, signal can also be declared in entity, architecture, or package part. And signals are used when inside a section of the sequential code, its its update is not immediate. Means if I am not the value, or the value which is not be immediately updated in your during your VHDL code using the sequential programming, because in VHDL you can use the sequential programming or the concurrent programming. In case of sequential programming, we are using a very important command, that is process. I will discuss these statements, VHDL statements, in further coming lectures. Till now, in the sequential language, we are using this command. This is very important, process command, and it is a sequential statement where the value it's not to be updated immediately. So signals are used where values of any parameter is not updated immediately. Then this type of data object is known as your signal. Now with this, I have completed the second data object, that is your signal. Now come on to the third data object, is that is your variable. That is your variable. This is the third data object used in the VHDL programming part. Okay, in VHDL, variable is used to update the value in a program immediately. So variable, actually it's unlike a signal, does not, and also it does not represent a wire in a circuit. Variables are objects in which data can be stored for use in a model, and its value can be changed as many times as necessary, and its value can be changed using the variable assignment statement. Variable, unlike constant and signal, it represents the local information, not the global. So it represents the local information, and it can only and only can be used inside the sequential code, that is process, function, or procedure. Its value is immediately updated. So this is the biggest difference between a signal and variable, is the value is updated immediately in case of your variable, but in case of signal it is not updated immediately. So this is the biggest difference between a signal object, data object, and second one is your variable data object. Now I will write the syntax and the examples for the variable data object. The syntax used for the variable data object is written as, with the reserve keyword variable, bolding this, variable name, variable name, then colon, then type name, type, hyphen name colon, sorry, square bracket start colon initial value square bracket close semicolon. Now I will write the examples for that. The example is variable z colon std underscore logic underscore vector round bracket start 3 down to 0 round bracket close colon equal to double quote start 1 0 0 1 double quote close semicolon. Next is variable bolding this keyword value colon integer colon integer range 0 to 10 semicolon. Next is variable, again bolding this variable control underscore data colon bit colon equal to single quote 1 semicolon. Okay, these were some of the examples for the variable, and I will discuss it one by one. Okay, starting from the syntax part. I'm starting it from the syntax part. As you can see, firstly, the class of the data object is written as variable, then variable name, colon, type, name, type of the variable, that object, then square bracket start, colon, equal to initial value, square bracket close, semicolon. Now, this is the syntax, this is the standardized syntax used for the variable. Now, I will explain this syntax with the help of 3 examples. The first example is variable keyword, reserve keyword. The name of the variable is z colon. The type of this variable is std, that is standard underscore logic vector, means of your vector type, and the value, initial value is given in the round bracket 3 down to. Okay, down to should be highlighted. This is also your keyword, reserved keyword. 3 down to 0 round bracket close, semicolon, sorry, colon is equal to 3 down to 0 means 4-bit data is there. So I am passing the value for that also. That is equivalent to here double quote 1001 means third bit, second bit, first bit, zeroth bit means third bit. 3 down to 0 means third bit, second bit, first bit and zeroth bit, and ending with your semicolon. Now come on to the next example is variable keyword. The name is value, colon, type is integer and range. Range for that. Range is also your reserved keyword. So it should also be bold. Range 0 to 10. 0 to 10 semicolon. Next is variable keyword. The name for the variable is control underscore data, colon. The type used for this variable is bit, colon, and passing the value. If I am passing the value more than 1 bit, it should be in the double quote. But if I am passing only single bit, then I have to put the single quote on that. So 1 in the single quote, value for the bit is 1, initial value, and ending with your semicolon. So this was the example and the syntax used for the variable command, variable data object. Now come on to the next, last one. Data object is your file. Last is your file. Okay. So file is actually used to store the data. As you know, in general language, file is used to store the data. File, that is fourth one, data object. So file, actually data object is a class of object that is used to store the data, and a file data object can be declared. Then this data object can be declared in the file declaration. I will write now the syntax used for file is file name, colon, file type name, then square bracket, that is open mode, square bracket close, is string under string hyphen expression here two brackets are there, square bracket, string expression bracket close, square bracket close, semicolon. Now next example for that is text text, open, it should be highlighted. Okay, firstly I have to write the file name also. Again writing this example is file stimuli colon text text open, this is in bold, read hyphen mode is should be highlighted because this is the keyword. The keyword is double quote C backslash home slash test slash STI dot here double quote. So this is the syntax and the example for the file data object. Actually, in the file data object, the mode specifies whether the file is to be used as your read operation, write operation, or in the append operation, or in the append mode. And if I'm not mentioning any mode, no mode is specified, in that case default mode will be your read mode. And in the last string expression, actually it specifies the link to the file in the host environment. So in the syntax, you can see that firstly I will write the your file name, then colon, file type name, and square bracket start, open mode. Three modes are there: read mode, write mode, append mode. Open mode, square bracket again start, open mode, square bracket, first square bracket is closed, is the keyword string hyphen expression, square bracket close, semicolon. So this is the syntax which is used for the file data object. Now come on to the example. Okay, for example, I have to write firstly the class of the data object, that is your file, with the bold keywords. Then the file name is your stimuli, colon, file type name is your text, then mode is open, written as read mode. If I am not mentioning here any mode, then by default this will be in the read mode. So read hyphen mode is keyword. You can see, compare it, this example with your syntax also, is string expression like double quote C backslash home backslash test backslash STI dot double quote ending. So this is the example for the your file data object. Now we have completed this concept, but related to this concept, one basic concept is left, that is, what is the main difference between your signal and variable data object. Okay, with this, now I will explain the comparison of your signal and variable data object. Now the further concept is your comparison of your signal and variable. Signal and variable. Signal, difference between between signal and variable. As I have already discussed with you, signal value is not updated immediately. But in case of variable, its value is updated immediately with the variable assignment statement. Now further differences between signal and variable is the signal uses the assignment operator, means assignment operator for giving the passing the value to a signal by using the assignment operator less than equal to. Whereas if I want to pass the value to a variable, it will be given by this operator. By this, using this operator, means if you want to pass the value to the variable, then it should be colon equal to, and if you want to pass the value to the signal, it should be less than equal to. This was the first difference. Second difference is that your signal represents the circuit interconnect, whereas variable gives you local information only. Now the third point is signal can be seen by entire board, means this is global. But variables are local. It can only seen in the inside the process, functions and your procedures. Now next part is signal may be of any data type, but a variable can be of your scalar or aggregate data type. These scalar and aggregate data types are the data types used in VHDL, which I will discuss in the further concept, various data types used in the VHDL. Now, next is during the simulation, signal need here more storage. But in case of variable, it needs less storage. Now, further difference is that signals are slower, these are slower, but this variable allows the fast simulation. Now, the last difference between the signal and variable is using signal assignment statement, the computed value. Actually, we have the value which is to be computed in the signal. Computed value is assigned to the signal object after a data delay. Means the value is updated after some delta delay. But in case of variable, actually, we are using the variable assignment statement and its computed value is updated or assigned immediately or instantaneously. So this was the difference between your signal and variable data object. Now come on to the further concept, that is data types. Okay. Now data types of, next concept is data types of VHDL. Data types in VHDL or of VHDL. Okay. What is the data type actually? We know that VHDL is a strongly typed language. So we have to actually specify the type of the data object. The four data objects, that is constant, file, signal, variable. So type of a data object defines the set of values the object can assume, and as well as set of operations that can be performed on those values. Actually, we have some certain predefined types, data types in VHDL. So there are certain predefined types and operations that can be performed on that object, data objects, particular data objects. And these predefined data types are contained in a package, and that package is known as your standard. And that package is known as your standard. So new data types we can also declare in VHDL using the your type declaration and also a set of operations. On these can be defined by writing the function that can return the values to this new type. There are actually various data types available in the VHDL, but we are basically broadly define these data types into 4 parts. Here I am writing type. These can be further divided into actually 4 parts. That is, first is scalar, second is composite, next is your access, and last one is your file. These are the 4 data types which are used, broadly classified into 4 data types. Further, scalar is also further divided into 4. First is enumerated, second is physical, third is your integer, and fourth one is your floating. Next, composite is also further divided into 2 parts. First is array, second is your record. So this is the diagram for the VHDL data types. This figure shows the VHDL data type. Now I will discuss with you one by one these types. So as you can see, scalar types is further classified into 4. First is enumeration, second is integer, third is physical, and fourth one is floating. And in case of composite, it is of your 2 types, array type, record type. Next, access types actually are equivalent to the pointers. We are using the pointers in C language also. So access is like equivalent to your pointers in the programming language. And last one is your file type, which gives us ability to declare the file objects with designer defined file types. So This was the introduction to the data type of VHDL. Now we will do this one by one also. So first data type I will discuss in further coming lecture. That will be your subtype. Then after this we will do scalar type, then composite, then access and file. So till then, thank you, and we will meet in the next lecture also.